Okay, we're going to look at integration by substitution. Now, integration by substitution, one of the reasons you use integration by substitution is if you've got a product, and there's a product, where one of the terms is actually linked to the derivative of the second term. So it could be the same as the derivative, it could be a factor of the derivative, or indeed it could be a multiple of the derivative. And that's a situation where you'd use a substitution integral. So we're going to look at two examples. The first example is this one. This is an indefinite integral where we've got this situation. And if I look at the term inside the bracket, the derivative of that is 2x, and that's the same as the other term, the other part of the product. Now, usually when you're doing a substitution, it is the term inside the bracket that is become u. So in this situation, u is 1 plus x squared, and everything then has to be worked out. Du by dx is therefore 2x. When you're doing integration by substitution, everything has to be substituted for, including the dx. So therefore I can write dx as 1 over 2x du. Therefore, when we now substitute, we're going to get 2x multiplied by u to the power 5, and if I substitute for dx, I get 1 over 2x du. 2x's then cancel, and that is the reason that an integral by substitution works. So left with u to the 5 du, which will integrate. Don't forget to use square brackets to show that you've integrated. Right, plus c. What you then need to do is substitute back for u to make it a function in x. So that will be 1 plus x squared all to the power 6 over 6 plus c. And that's the first example of integration by substitution. What I'm now going to do is do a second integration by substitution, but this time I'm going to use a definite integral. And this integral this time, we have x limits 0 to 2 of x multiplied by x squared plus 1 all to the power 3 dx. And it's important to remember that everything has to be substituted for, the dx and indeed the x numbers. But just to check that it is a substitution, if I do the different derivative of what's in the bracket, I get 2x, and x is a factor of that, therefore it's a substitution. But like the other example, u then becomes x squared plus 1, du by dx is 2x, therefore dx can be written as 1 over 2x du. So now, therefore, if I substitute, well, just before I do substitute, I'm going to substitute for these x values as well. So if I substitute the x in there, I will get each of the x numbers turned into a u number. So u is 2 squared plus 1, which is 5, that's the upper limit, and u is 0 squared plus 1, which is 1, that's the lower limit. So now all I've got to do is substitute. The limits have become 1 and 5, x, this becomes u to the power 3, and dx is 1 over 2x dx. This x then cancels, and this will simplify to half the integral between 1 of 5 of u to the cube du, and that there should be du. So then when I integrate, I will get u to the 4 over 4. That simplifies to an 1/8 of u to the 4. These are now u numbers, so I don't now need to substitute back in. So I've got 5 to the power 4 over 8, and 5 to the power 4 is 625 over 8. Take away 1 over 8. That's inside the bracket, and all of that has to be divided by 8. So that gives me 624 over 8, which is 78, and that has to be divided by 8. 78 divided by 8 is, and I just need to use my calculator, 78 divided by 8 is 9.75. And that, because it's an integral, is units squared. And that's how to do an integration by substitution.